Hi there. My name is Chet Wiltshire, and today I'm starting a video series documenting my experience attempting to recreate a open source project by Sky Guided, and the project is called an inductively coupled radio frequency plasma toroid in xenon gas. Let me show you a quick video of what this is, and then I'll break down why I want to build it. Okay, now that I've shown you this insanely cool project, let me break down why I want to do this. For your understanding, I currently work on Hall effect thrusters at a small company, and in doing so, I've learned a lot about what components we use, the circuit design, how Hall effect thrusters work. I've always loved this experience, but it's not easy to share what that's like outside of work. I was looking for a project that I could build that involves something with plasma, and so when I found this, I just knew I really had to learn how it works and really wanted to build my own. I'm not sure how this will turn out, but fortunately, this will not be my first time trying to assemble a printed circuit board and test it to see if it's successful without letting out the magic smoke. I do expect that I will learn something new. This is already turning out to be way harder to document than I was expecting, but it's also a good thing that I'm getting in front of the camera again. Okay, so one of the goals for this project for myself is to, instead of using a soldering iron and a roll of solder, I instead want to use a stencil to cover all the pads I want to solder to. That involves using solder paste and a card and the stencil to apply it to the pads, and a hot air station. So I just recently got this and I want to try using it. And I'm not sure how successful I will be in doing that. With that goal out of the way, let me go over the requirements I've set forth for this project. The first requirement is that it needs to be safe to operate and operated safely. This system uses high voltage and also oscillates at a high frequency. I'm not going to explain everything in detail, but what you do need to know is that this system should not be operated near sensitive equipment, people that have pacemakers, and it also should not be run unattended. You've been warned. The second requirement is that it needs to be pushed to start. This is already part of the design, and all I'm really doing in putting this requirement here is emphasizing I don't want to require a Tesla coil, spinning the glass ball, or some other external source to be necessary to start the ionization of the xenon to get the plasma toroid. The third requirement is that it needs to sustain the plasma toroid for at least 5 minutes. I'm not going to require any more than that to consider this project successful. The fourth and last requirement is that it needs to be portable. I think this is already part of the design as well, that you can build it with one circuit board to hold majority of the components and transport a glass ball of xenon that is around just a liter in volume. And as I understand it, Sky Guided also is able to operate this off a battery bank, so I would assume that this will also be relatively straightforward. With our 4 requirements out of the way, I'm going to dive into the project page and go over how I acquired the components, and then after that, we'll start the assembly.
So after all those warnings, maybe you're still asking, hey, can I build one of these? And my answer is, hell yes you can. You should. My entire build and my entire design is all open source. On my hackaday.io page, I have a full schematic, I have a bill of materials, I have PCB design and fabrication files, I have more.
All right. And I went to verify this, and it's all true. Sky Guided has done a fantastic job. You'll see a general overview here of what's required. The hardest thing by far to acquire is the low pressure ball of xenon. I tried reaching out to Wayne, but I wasn't able to get a hold of Wayne Stratman in time. I decided to go instead to Bagel Gen, where you can order bagel flasks. This is a photo gallery, but if you just go to the products page, you can order a Bagel Gen, which I did not do, but I did order a bagel flask. In this case, there's a whole array of bagel flasks you can order based off the effects you would desire. However, I'm pretty boring. I just went with the Xenon White bagel flask. The next thing is the primary circuit board. So in the instructions, the link to PCBWay is there. It'll take you to this PCBWay project page, and you can click Add to Cart to auto-populate the PCB. So when you do that, it'll fill all this out for you. I tried to see if they could do a black solder mask, but that turned out to be an issue with the spacing between the pads for one of the integrated circuits, so I just opted back to green, which shouldn't be an issue. And the only other thing is you have to add a stencil if you would desire, like I am, to use a stencil and solder paste as opposed to manually soldering on each surface mount device. With that, that brought the order to just over $100. The BOM is included below. There's the Gerbers and the BOM to download. Okay, when you download the BOM from PCBWay under this particular project, you'll open this tab and you'll find useful information here at the top. We have item numbers, references, or designators as I call them, the quantity, the description of the item, the package, the manufacturer and manufacturer part number that was selected by Sky Guided, and notes. So I went ahead and opened up a new tab so I could add a few more things to this. So I went through all the manufacturer part numbers on DigiKey's website, and I highlighted each one after I added the part number and quantity, and I bolded anything that was previously not in the BOM or that I needed to update. The only two things that I want to call out is the heatsink assembly part number. I had to order the piece parts instead of the assembly part number, which was easy enough once I reviewed the assembly part number data sheet. And the next thing was a reference to Arc Striker fly wire with a note hand assemble from 16 gauge insulated wire or similar. When I went to the video where this is explained, I was able to catch that this is up to 3000 volts.
This transformer converts the 300 volt pulse to as much as 3 kilovolts on this little wire.
So I picked out wire that was rated for that voltage, and that's this part number here. So with that, this BOM was mostly complete, and if I roll those together, so looking at my order history and rolling up the costs, you can see here between my orders to DigiKey and PCBWay, we're up to around $250 if we account for the additional power supplies, the fans, and the solder that I've ordered. That brings it up a little bit more, and by far the biggest cost is the bagel flask, or whatever you want to call the glass ball of xenon. Each time you order from PCBWay, it defaults to 5 PCBs, so I'm getting more than enough for what I need. I ordered twice as much of everything aside from this bagel flask, since it's the biggest item. And I also ordered solder paste and 16 gauge wire, which are essentially one-time purchases for me. If I roll up the total cost spent so far in this project, minus 3D printing, filament, and the inserts and the screws, we're around $650 to spend, but if I account for how I've doubled essentially everything besides the bagel flask, it's actually less than $500 for this build. All right, that's a good overview of the build materials. All right, it's about time we start putting components down on our board. When I got my order from DigiKey, I got this paperwork that you can see here. For this example, I'm going to reference line item 4, which is a capacitor. It's just a single capacitor in the bag, but you can see the part number and the customer reference there. CUST C6 is the customer reference or the designator. And each one of the line items in this entire order also has its own bag. So you'll see here, there's the line item 4, there's the part number, and there's the C reference, C6. So when I'm reviewing that I have all the parts that I need to put on my board, I'm also able to quickly reference, I need to grab this bag with this designator or this reference, and I check that against the layout when I put the components down on the board. All right, so I've opened up the Gerber files. They are, I think, originally designed in KiCad, so I chose to download that software and to use that to open up the Plasma Toroid Unified rounded.KiCad_PCB. So I've opened up that underneath the original project folder, and I've left it as the default of all layers. So I'm going to change this to front assembly view, and I'll zoom in on the area we're adding components. And I'm going to hide a couple layers. So right now, the silk screen, that's what the white ink is that we see on the board. I'm going to go ahead and hide that. And I'm also going to hide the courtyard. Those are the pink outlines that are not too helpful for me. And really, the information that was missing from the front silk screen that I can see in the software is the fab layer. So if you imagine the board, this is pretty much what I'm seeing on the front face. The purple layer called front mask. That's the mask where the pads are that we see. But with the fab layer on, I'm going to zoom in on one of these areas so it's pretty clear what we're trying to do. So for components that are symmetrical, such as U1, I do need to make sure I've got the correct pin 1 so that I don't flip it around and burn up the chip. So I can see here the white outline in the fab layer shows one corner having a 45-degree angle. That's helpful to understand that that's a pin 1, and it's also confirmed by reviewing the mask. It actually does call out each pin, so this is pin 1. And if I also look at diodes, this is also apparent. The diodes, for instance D2, we can see what pin 1 is, and we can also see that similar shape, that 45-degree angle being on the bottom. Some of the other diodes, they'll have this symbol instead, so it's helpful to understand the direction it needs to go. With that, I think I can find the designators in this layout, and I can start mounting components. It's time for the build montage. If you don't like this music, feel free to put on something else, but for myself, I'm going to put on some cool techno, maybe some funk, some other music, I don't know.
Let me tell you why you're here. Do you know what I'm talking about? I don't care what people say. I gotta stay awake. I don't care what people say. seeing it in my dreams.
And that does it for the build of the Plasma Toroid. I really appreciate all the effort that went into designing and documenting this project on hackaday.io. The page has lots of photos that I've referenced just to make sure I got things soldered in the right place. The biggest problem thus far was getting the L1 inductor soldered to the board. I had to add legs to it. I just wasn't confident that I was successfully soldering it, as you probably saw in the middle of the video. And next time, we'll try to get the igniter and drive circuit working. I have successfully tested the push to start, but I have not gotten this thing to oscillate. Thanks for watching. If you enjoyed, consider leaving a like, sharing the video, and leaving a comment if you have any questions or advice. I really do hope that you consider following this series. I intend to post part 2 going into testing of this in about a week. So thanks again. I'll see you in the next one.